This is problem number 1 from section 3.4. In this problem, they ask us to solve each equation and inequality. We have 3 parts. We have a quadratic equation, obviously just with an equal sign, and then we have a quadratic inequality with the less than and a quadratic inequality with the greater than. And when you look at this, you think this is going to take a lot of work. But actually, anytime you solve any quadratic inequality, you start by taking the inequality sign and replacing it with an equal sign and just solving a quadratic equation for its roots. After you do that, then you just have to draw a number line and determine where the solutions are for the less than or equal to sign or the greater than or equal to sign. So there's only like one extra step to solve an inequality than there is to solve an equation. So let's go ahead and start by solving this equation in part A. Obviously, I think that looking at this, it's a quadratic formula problem right away, quadratic equation. We've got factoring, we've got completing the square, we've got square roots. None of those seem to be probably what I want to do there. So I'm going to go straight to the quadratic formula. And the quadratic formula gives you x equals negative b plus or minus root b squared, so on and so forth. We can say that b is negative 32, a is 16, and c is 15. So we can start by saying x equals negative 32 plus and minus root, this will be negative 32 squared minus 4 times a, which is 16, times c, which is 15, and that's all over 2 times a, which is 16. Now I'm going to use my calculator to do most of this work. So we can get rid of the quadratic formula. Okay. We're going to go inside the square root, we're going to say negative 32. We're squaring it, minus 4, and I'm writing it just how it is, 16 times 15. Hit enter. 64. And then I need to take the square root of 64. And we know that's going to be 8. So we end up with 32 plus and minus 8 all over 32. So now we're going to simplify this a little farther, and we're going to say that this equals 32 plus 8 over 32, or 32 minus 8 over 32. So x is going to equal 32 plus 8, that's 40 over 32. We can reduce 40 over 32, put that in the calculator. Let the calculator do the reducing, that's 5 over 4. Or x equals 32 minus 8 divided by 32. Again, let the calculator do the work for us, 3 over 4. So our roots are 5 over 4 and 3 over 4. That's the solutions to the first, to part A. That's the solution for part A for the quadratic equation. Now part B, this is where it gets, this is where we get the extra step here. For part B, we're going to draw a number line. And we're going to make sure that we write this number line, this negative infinity out here, obviously, and this is infinity. So we want the smallest number here, which is 3 over 4. The largest number here, which is 5 over 4. And what we're going to do is we're going to pick numbers to the left, in the middle, and to the right of those numbers, and we're going to plug them into this inequality in part B to figure out, does this number, or sorry, to find out, do these solutions work? So I'm going to plug in 0, because that's left of 3/4. I'm going to plug in 1, because that's between 3/4 and 5/4, and I'm going to plug in 2. And remember, I'm plugging it into 16 z squared minus 32z plus 15, and we're looking at the less than or equal to 0. Now I'm going to do this pretty easily using my calculator. So first of all, if I plug in 0, this one's pretty easy to figure out. If I plug in 0, that cancels this term and this term. I'm left with 15 less than or equal to 0. Is 15 less than or equal to 0? No. So this part of our number line, that part's not, there's no solutions there. Now for the 1 part, we're going to plug 1 in, and I'll show you how to do this in the calculator. So we're going to use the store button right here. We're going to say 1 store as x, and then we're going to just type in the equation. And this makes it, this streamlines it a lot, especially if you're using a TI-84. So 16x squared minus 32x plus 15. Tells me I get -1. So when I plug all those in with 1 plugged into it, I get -1 for this. Is -1 less than or equal to 0? Certainly is. So this, between 3/4 and 5/4, those are solutions. And then I'm going to pick 2. So now all I have to do is do 2, store it as x, and then just go grab that equation, and I get 15 again. So 15 less than or equal to 0, we know that doesn't work. So our solutions lie between 3/4 and 5/4 for part B. And because it says equals 3/4 and 5/4, when I write them in interval notation, well, I'm going to use brackets because they can equal those solutions. All right, part C then. All I do for part C is do the exact same thing that I just did, except for now I'm going to take this number line, mark 3/4 again, 5/4. Still going to plug in 0, 1, and 2. The only difference is now I'm looking at 16z squared minus 32z plus 15, and I flip the inequality sign. Okay, but it doesn't change anything, and I already have all the stuff in here to work with. Now, when we plug in 0, we already know it right away. 0 cancels that term and that term. 15 greater than or equal to 0? Well, of course, 15 is bigger than 0. When we plug in 1, though, let's go 1, store it as x again. Now, we already have those answers up there. I know that. It's sitting up there, but we might as well just practice doing this. Pull back in the 16x squared minus 32x plus 15. Hit enter. -1 is what I get when I evaluate it with a 1 plugged in. -1 greater than 0? Nope. Now I pick 2, store it as x. Just grab that equation again. And it tells me I get 15 again. 15 greater than 0? Oh yeah. So check that off. So my solutions then go from -infinity all the way up to 3/4. So -infinity to 3/4. Bracket on that, parenthesis there. Union 5/4, because remember it says equals right there, comma infinity. And those are the solutions. And that's how you solve quadratic inequalities using your quadratic equation. And this is how you solve them every single time. I know there was a few steps here, but you're not going to have to solve all 3 every single time. Usually you just solve the quadratic equation and then you do a number line to figure out your solutions.